Hello everyone, my name is Sarp Özartam and I'm an industrial engineering student at Bilkent University. This is Physics 102 class and I'm going to show my lab project. In this experiment, I will be studying the change of induced EMF due to change of independent variables such as number of turns of a coil and the speed of the magnet. For this experiment, we need the following equipments: voltmeter, magnet, 10-turn coil and a 30-turn coil, and a Gauss meter. With these equipments, a setup was formed. Faraday's law of induction and Lenz's law will be used during the experiment. This law states that the electromotive force induced in a conduction coil is directly proportional to the number of turns of the coil and the rate of change of magnetic flux in the coil. Faraday's law states that the EMF is also given by the rate of change of the magnetic flux, where epsilon is the electromotive force EMF and the numerator is the magnetic flux. The direction of electromotive force is given by Lenz's law. Lenz's law predicts the direction in which current will flow, whereas Faraday's law indicates the strength of the electromagnetic field generated. In practical applications, magnetic induction involving multiple coils of wire is commonly encountered, where each coil contributes the same electromotive force EMF and the additional term N, representing the number of turns, is frequently incorporated for clarification. Therefore, induced EMF is directly proportional to number of turns and the magnetic flux. The minus sign implies direction. These following formulas will be used during the experiment. In order to measure dB over dt, Gauss meter was used. dB over dt was approximately 130 Tesla. This will be used in theoretical part. First, I connected a coil with 10 turns to voltmeter and I passed the magnet through it once in a second. Then, I connected 30-turn coil to a voltmeter and I passed the magnet through it with the same speed. I recorded EMF values in a table and I calculated the error. I plotted a graph with this data. We can see that number of turns is directly proportional to induced EMF. Then I connected 30-turn coil to the magnet, but this time I increased the speed, which I passed the magnet through coil twice in a second. I recorded EMF values in a table and I calculated the error. I plotted a graph with this data. We can see that speed of the magnet is directly proportional to induced EMF, since increase in speed increases dB over dt as well. The error percentage is high in this experiment. There were systematic and personal errors. For example, the value in the voltmeter was rapidly changing. This caused a lack of precision in measuring EMF. Another inaccuracy is the unreliability of the human hand, and this is a visible personal error. The goal of the experiment was to observe how induced EMF changes when changing the independent variables, which are number of turns of the coil and the speed of the magnet. The Faraday's law and Lenz's law are used. All the data are neither tabulated and the line graph is plotted. The main result of the experiment is that with the increasing number of turns of a coil, the induced EMF also increases proportionately, and the other part of the experiment indicates that as the speed of the magnet increases, the induced EMF also increases proportionately. The experiment could have had more successful results if it didn't require that much human work that resulted with high personal errors. And thanks for watching.